Okay, so this lesson is called power to power rule of exponents, as opposed to the product rule, which we discussed before spring break. So the power to power rule of exponents, what it is if there is a power on the outside the parentheses, it's almost like we're distributing into the power on the inside of the parentheses. So I'll show you what that looks like in a second. But again, notice how this one, there's no multiplication sign. What's happening is that there's a power outside the parentheses. So when we're raising a power to another power, the basic rule is that we're going to multiply the exponents. So if you remember from last time, when we were using the product rule of exponents, we were adding the exponents on the same base. But now, if we have an exponent outside parentheses, we have to multiply it with all the exponents inside the parentheses. So what that would look like is we're still going to keep this base, so the base is x, but now we're going to be multiplying those two exponents. So we keep the base, which is x, but then we're going to multiply 2 times 8 to get 16. So again, it's almost like if you see this arrow, it's almost like we're using the distributive property, but now with exponents. So if we take a look at this second example here, notice how both of them are negatives, but we're still really going to use the same rule. If we have an exponent outside of the parentheses, we keep the base, which is y, but we're going to multiply those two exponents. So it'll become y to the 12th. And again, two negatives do make a positive, so it becomes positive 12. All right, so these next two examples, it does get a little bit more complicated. So before we just had a base and we had an exponent and then an exponent outside the parentheses. But now notice we have these coefficients. So last time when we had coefficients, we were multiplying coefficients. But now with the product rule, it does become a little bit different. So the big thing that we have to remember here is that if a base does not have an exponent, that the exponent is 1. So we notice how this 3, we normally see it as a coefficient, but it's actually a base that has an exponent of 1. So 3 is the same thing as 3 to the first power, because 3 to the first power just means that you have 3. So what we're going to do, just like similar to the distributive property, is we're going to be multiplying that exponent by everything inside the parentheses. So the 2 gets multiplied by the 2, and the 2 gets multiplied by the 1. So I'm keeping my bases, which are 3 and x, but then I'm multiplying these exponents. So it does get a little bit tricky. I don't expect that you understand this completely the first time you see it, but the big idea here is that if something doesn't have an exponent, or if a base doesn't have an exponent, the exponent is 1. So we keep the base of 3, but 2 times 1 becomes 2, so it's 3 to the second, and 2 times 2 becomes 4, so it's x to the 4th. Notice how these bases stay the same. The only thing that changed was we multiplied the 2 with all of the exponents on the inside of the parentheses. And then when we have 3 squared, we actually know to simplify that. You can either enter that in your calculator or know that 3 squared is actually 3 times 3, so this becomes 9x to the 4th. Notice how what I did not do is do 2 times 3 and make this 6. So that's a big mistake that happens, is some people just will multiply the exponent by the coefficient, but that's not true. You always have to multiply exponents by the exponents on the inside. So that's why 3 squared will not be 6, it is 9. Okay, so the next example that we're going to look at is 5x to the cubed, all to the 3rd power. So again, notice that we have a 5 and an x here. The x has an exponent of 3, but the 5 has nothing here. So since the 5 has nothing here, we know that that 5 has an exponent of 1. But again, then we're following the same steps here. So the exponents are 1 and 3. So that 3 on the outside gets multiplied by both of those exponents on the inside. But then the bases are staying the same. So since the 1 is on the 5, we'll do 1 times 3 and put that back on the 5. So what that would look like is it will be 5 cubed, because 3 times 1 is 3, and x to the 9th, because 3 times 3 is 9. So again, it is a little bit confusing. There's a lot going on. But again, you want to focus on making sure you're multiplying the exponents and keeping the bases. So 5 cubed can be simplified, because 5 times 5 times 5 will become 125. If that's not something you know off the top of your head, you could always enter that into your calculator too. But again, multiplying our exponents now and keeping the bases. Okay, so 2 more examples now before you try some on your own. So now here we have 2 different bases again, but both of them have exponents, so that makes our job a little bit easier. So the x has an exponent of 2, the y has an exponent of 3, and on the outside we have a 2. So again, we're distributing the 2 in. So we're keeping the x and doing 2 times 2 to get 4, and then keeping the y and doing 2 times 3 to get 6. So again, a lot like the distributive property, but we're keeping the exponents on top and the bases on the bottom. And there's nothing we could do here to simplify, so we leave it. A good idea is I know that you're doing a lot of these problems on Kami when you do your examples. However, these are actually a little bit easier if you write them out and put the arrows. So I would highly suggest maybe having some paper next to you, or maybe writing the problems out on a separate piece of paper so you can do a lot of this scratch work on your own. And the last example here is probably one of the harder ones we'll see because we actually have a coefficient and 2 different bases. So before we can start this, notice how there's like 3 different bases here, including that coefficient. So we want to make sure each of them have an exponent. So the 2 doesn't have an exponent, so we have to put the 1 on it. And that x also doesn't have an exponent, so we put the 1 on it. But after that, all we're doing is distributing that 2 into all of those exponents. So we keep the 2 as the base, but then we do 2 times 1 and get 2 squared. 2 times 1 is 2 on the x, and 2 times 4 is 8 on the y. And because we did have a coefficient here, we can simplify 2 squared. 2 times 2 becomes 4. So it's 4 x squared y to the 8th. Again, we're distributing that 2 in and making sure that we put 1s on anything that didn't have an exponent. Another thing to point out is that we did start with 3 different bases here, so you want to make sure when you simplify it that you do have those 3 different bases. So there's no reason that the x should go away, the y should go away, and your constant should be there as well. Okay, so now that you've seen some examples, I'm going to give you time to answer these 2 questions, and then I'll explain them in a second. So with the first one, we only have 1 base. So that's x and 1 exponent, 3 on the inside and then 5 on the outside. So that's like one we just saw where you just do 5 times 3 and simplify it x to the 15th. The second one here, we have a 3 and an x as our base. So the 3 does not have an exponent. So you'll typically find that with coefficients, they don't have exponents, so you have to put your own on it. So we'll put the 1 there, and then we'll distribute the 4 into both of those exponents. So we keep my bases, which are 3 and x. 4 times 1 becomes 4, 4 times 2 becomes 8. And then the last thing you need to do to simplify is just evaluate 3 to the 4th, which is 3 times 3 times 3 times 3. Something easy you can just enter into your calculator will become 81x to the 8th. So there are some example problems for you to complete as classwork and submit them. I will send you the answer key after you submit them, so please check out that because if you didn't get a good grade the first time, you can look at the answer key and fix them. So please feel free to email me if you have any questions, and good luck.